All right, guys, so welcome to the beginning of Chapter 4. And the first section in Chapter 4 is called Detours and Midpoints. Okay, Detours and Midpoints. All of Chapter 4 is going to be about lines, lines in the plane. So we're going to be talking about lots of unique things and, of course, getting triangles congruent. So a detour in a proof is exactly like what it sounds like. It's like a detour when you guys are driving in driver's ed. Obviously, you can't go that way, so you have to make a different way. And when you make that different way, you end up in the same spot. Okay, that's what we're going to do. We're going to try and get these pair of triangles congruent that we need congruent. And you know what? We might not be able to. And that's okay. If we can't do that, we're going to find another pair of triangles that we can get congruent, make those congruent to each other, use some of that information to then prove the triangles that we originally wanted. Okay, so we're just going to take a little detour. Here's the procedure. I like that they did this. So first you're going to determine which triangles that you want congruent. You're going to attempt to get them congruent. Okay, you're going to identify the part that must be proved congruent in order to get those triangles congruent to each other. And remember, okay, then it's not going to work, but you're going to have those. You're going to find a different pair that are pretty ready to get congruent to each other, and they are going to contain the part that you needed in step 3. Okay, then you're going to prove those triangles congruent to each other to use that information to prove the original triangles are congruent to each other. Okay, so that's what we're going to be doing for detours. I put an example here for you guys. So in the example, we made it very obvious. We're trying to prove that ABE is congruent to ADE. And if you take a look at this, I see that I have my given information here. We have AB congruent to AD, so that's a side, which is awesome. We have this reflexive side right here, but I don't see any more information. Okay, so now what, right? So this is the detour that I'm talking about. We cannot get the blue triangle congruent to the pink triangle. I would need either this orange dot right here, or I would need this third side right here. So I'm going to make a little note to myself. If I can get angle BAC congruent to angle DAC, or if I can get BE congruent to ED, then my life would be complete because I would have side, angle, side, or side, side, side. Okay, so that's my goal. That's my end goal, to try and get a piece of this information. Unfortunately, right now we can't, so we're going to regroup. So the next thing we do is let's pick out some different triangles, right? So let's try these triangles right here. I see that we already have a side right here and a side right here. We have this reflexive side, and we don't have any more information. Okay, so now let's think outside the box. Let's go bigger. So sometimes also highlighting the information that you have is really helpful in this. So what I mean by that is if I were to highlight this and this, that's what I have, and highlight this and this, that's what I have. And it's like, oh, wait a minute, I can get these bigger triangles congruent to each other. Because as I trace that blue side and this pink side, I see that that is a reflexive side. So I can probably get these triangles easily congruent to each other. So step 1, AB is congruent to AD, given. Step 2, BC is congruent to CD, given. And step 3, I already said my reflexive side. AC is congruent to AC, and that is any segment is congruent to itself. Then we can easily prove that the triangles are congruent. So triangle ABC is congruent to triangle ADC, and that is by side, side, side in step 1, 2, 3. Okay, so I have these triangles congruent. Why are these triangles going to help me? Well, I'm going to take a look back at what I needed. If I could get BE congruent to ED, which I can't because that's not part of the triangles that I proved congruent, or if I could get this angle congruent to this angle, then my life is good. And guess what, guys? I can get those congruent to each other because those big triangles are congruent to each other. So because the big triangles are congruent, I know that angle BAC is congruent to angle DAC. And again, if triangles are congruent, then their corresponding parts are also congruent. That's CPCTC. If triangles are congruent, then their corresponding parts are also congruent to each other. And now you're asking, how does that help me? Well, now I have BA right here, this step. This is a side to my triangle right here. I have this step right here, which is an angle to my triangle. And I have this tiny reflexive side. I have AE congruent to AE, which is another side. And again, that's the same as number 3. Any segment is congruent to itself. That's the reflexive property. Okay, so I now can say what I'm needing to say, which is triangle ABE is congruent to triangle ADE, and that is by side, angle, side, and that is in step 1, 5, and 6. So we had to take a detour. It's okay, we finally got accomplished what we needed to get accomplished. My next thing are midpoints. Midpoints you guys are going to see all over the place. Midpoints are basically points that are in the middle of a segment, okay? In the middle of a segment. Middle of a segment. Okay, so it's very easy if you have a straight, like let's say this was our number line, right? And this is 3, 4, 5, 6, 7, 8, 9. And this is on our number line. It's really easy for you guys. Maybe in grade school you guys kind of counted 1, 2, 1, 2, 3, 3. This is the middle right here. So you knew that 6 was in the middle, okay? Algebraically, what you guys are doing, because obviously the middle of 3 and 9 is really easy, it's 6. But what you guys are actually doing to find the middle is you are finding the average. You're adding those together and you're dividing it by 2. And that's where that 6 is yielding algebraically. So that when we do get to more complex problems, that's essentially all we're doing. So if you look right here, I took it off of the x-axis and we put it as three-dimensional in the x and the y-axis. So now we don't want to just find the middle of the x's, we also need to find the middle of the y's. And we do so the same way, okay? We take a look at our x's, we add them together, and we divide by 2. And this is apparent right here. You add the x's together, divide by 2. And you do the same thing for the y values. You add the y values together, and you divide by 2. Okay, so what you're doing is right here, you're finding the middle of these x's, then you're finding the middle of these y's, and where those two meet, that is your midpoint. You're finding the middle of the x's, and you're finding the middle of the y's. So just as a quick example, let's say we wanted to find the middle of 2, 7, and b is -3, 12, okay? Again, to find the midpoint, okay, to find the midpoint of the x's and the y's, so we call that the middle x and the middle y, we add the x's together and divide it by 2. We add the y's together and divide it by 2. That's going to come out as your midpoint. So -1/2 for the x value, and that's okay if it's a fraction, and 19/2. I prefer fractions over decimals, but up to you guys. So that would be the middle of that point right there. Now, guys, I also want you to use your brain. Sometimes it's really easy, like if the point was 1, 6, and 3, 4. I just want you to use your brain. What's in the middle of 1 and 3? Right? What's in the middle of 1 and 3? 2. What's in the middle of 6 and 4? Right here. 5. There's your midpoint. Of course, if you want to add them together and divide by 2, that's perfectly fine. But I do still want you guys to use your brains here. So there are 3 examples that we are going to cover in class with midpoints and detours.